Welcome back, everybody. I'd like to introduce our next speaker. Thank you. I'd like to introduce our next speaker, Charan Ranganath, who's going to talk to us today about time to get real about episodic memory.
Thank you very much. Well, I just want to express my thanks to Anna and Sharon for inviting me to do this, especially because I know little to nothing about concepts, objects, or actions. And so I'm really hoping to learn from you during this Q&A period. Well, a little bit about events, thank God. And actually, I just want to thank the other speakers. I think this really reduced my workload in this talk because so much of it was set up, and especially I think Janice's talk really flows nicely into what I'll be saying today. The other thing I want to say is I'm going to try to do it, but basically anytime I say we, I just mean these people in my lab, and especially Zach Rea, Brendan Cohn-Shee, Alex Barnett, Walter Riley, and Angelique Delarazan. And Angelique's going to be applying to grad school in the fall. She is absolutely fantastic, so I definitely recommend that you get in on the action if she applies to your place. So let's get on with it. So I study episodic memory, as I said, not concepts, not objects, not actions, although it's in all that stuff. So, and so I think Anna said at the beginning of the introduction that you're all studying events and you don't know it. I'll start off mine by saying everyone who studies episodic memory is probably not studying events. They don't know it. What I mean by that is from going back to Ebbinghaus, basically, who taught himself nonsense syllables and looked at his ability to remember it. We've studied memory for the most part by looking at the ability to kind of, you show people some items and then you have people recall the items or recognize the items. It can be faces, it can be words, it can be whatever, but that's kind of the bread and butter paradigm. And so, you can get more interesting in thinking about it. So for instance, many people will argue, and I like this idea that even though you encode particular words in these kinds of things, that there's kind of a subjective temporal context. So there's something that's changing in your brain over time, or a combination of psychological states that gradually changes. And so when you learn an item, you're not really learning the item, but you're learning to associate it with the temporal context. And so that's kind of how we operationalize an event, right? And so now I'm going to show you a different kind of event, just to kind of keep people awake, those who have jet lag like me. So I'm just going to show you an event, or a set of events. I want you just to study it for a moment.
Come on, get the lid up. Come on, Dad, we want to go to Duck Gardens. Mom, tell them we're going to Duck Gardens. Oh, great. Dad's dead. Have you been eating that sandwich again?
Sandwich.
Jeez, we hardly made a dent in that 10-foot hoagie.
Oh, give it a good hope.
You've been eating that thing for a week. I think the mayonnaise is starting to turn.
2 more feet and I can fit it in the fridge.
Homer, I found this behind the radiator. I really think you should throw it away.
Suggestion noted. Marge, I'd like to be alone with the sandwich for a moment.
Are you going to eat it?
Yes. Oh.
You look terrible.
I don't care. I'm going to Duff Gardens. So cold.
Your lips are turning blue. I think you better stay home.
No! Duff Gardens! Hurrah!
Okay, I could watch that forever, but and actually I probably used up half my talk time now. So now just for fun, I'm going to ask Alex Martin, recall as much as you can from that video.
It's going to take me as long as that.
No, you'll compress it. Didn't you see Janice's talk? All right, just start me off. You don't have to go through the whole thing.
Well, Mark and Lisa came in this morning, took the garbage down, and there was dead Homer, except he wasn't dead. And then we learned why he was in that state.
Okay.
Condensed.
That's very condensed. And that's perfect because basically nobody in their right mind would remember it like this, right? I mean, but these were all items that were in that video, right? I mean, but nobody would give a disconnected set of items like this. So we say we study memory, but this is not how we remember. So it's not a matter of ecological validity. I don't care about ecological validity. I really care, though, about are we studying what we think we're studying? And so I've kind of had this paradigm shift in my head about how do we study memory in the real world, right? And this is just a quote from Frederick Bartlett, who's kind of one of the two sort of major figures in starting memory research, which is, in a world of constantly changing environment, literal recall is extraordinarily unimportant. And so I'm not going to say that necessarily the work I'm going to show is important per se, but I think it's important to understand something about that bigger structure of real events. And so you've heard a lot about this, but basically real life events play out over a long time scale. They involve dynamics between people, places, and things, and they have a meaningful temporal structure. All of those were evident in the video that I saw you. You could segment those into different events, but you could also draw connections across the events. They involve different characters and different locations, and even different time periods. Now, that's a cartoon. It's not real life, but I think these are the kinds of things that we need to start studying in memory research. So you're going to hear a lot about different kinds of terminology in the field, and I'm just going to give you kind of the way we're currently thinking about this right now. Actually, first, before I do that, I'll just kind of say there's an interesting kind of starting point for this, which is the work of Frederick Bartlett. And so, he did this study, and it's actually it's not clear how well all the details replicate, but the point of the study is kind of cool, which is that he had a bunch of British subjects learn a story that was a Native American story called The War of the Ghosts. And so they recalled it repeatedly over periods of time. And one of the things he found was the more times people recalled it, the shorter the recalls became, and the more coherent they became, and they distorted the stories in ways that basically made it conform to their cultural knowledge, okay? And so what that tells us is a few things, which is, first of all, knowledge is kind of that structure, so to speak, that episodic memory is built on. And so you have episodic memories allowing you to build knowledge, and then knowledge is the foundation of episodic memories. But also it talks about the idea that memories are dynamic. They're not necessarily static. Now, Bartlett's work inspired a lot of people studying memory as distortions and constructions, and that's all been great work. There's been definitely good stuff coming from it. But a lot less has been devoted to understanding what Bartlett was talking about with schemas. And I think this was a very big topic in the 70s, and then it just kind of vanished for a while. And now it's become very big again. It's kind of become hot. Although I think the field has kind of developed a little bit of a fetish about event boundaries without really talking about what events are. And so, again, I think it's important to understand what these things are. So the way I'm going to talk about it is an event. Actually, I'll talk about an event as a sequence of experiences that fit within a particular place, time, and situation. And over the course of life, I'm not actually going to get into all of these terms in my talk, but I think it's important for you to hear the assumptions about how I'm thinking about it. So we have knowledge about events. And so, you go to enough weddings, you go to enough funerals, you go to enough symposia, and you develop knowledge about how these events work. And those we're going to call event schemas. Now, during an event, like even during the movies that you've been seeing in a lot of our talks to keep everyone awake, you are using those schemas to instantiate a particular mental model. So in the past, I've referred to situation models, which is what comes out of the language literature, but in event cognition, Jeff Sachs likes to call it event models, so what the heck, I'll go with event models, I like events. And so, but the idea is that this is a particular working memory sort of representation, but it's activating a specific set of knowledge representations that's allowing you to understand what's happening now, but also predict what's going to happen in the near future. And according to Sachs's event segmentation theory, when the event model fails, and I'll be a little bit more neutral about what that means, but when the event model fails, you basically dump it and you pull up a new one. That new event model could be coming from the same schema, or it could be coming from a totally different schema. There's lots of evidence for this idea these ideas that I won't get into. But the way I'm thinking about this is that, if we're trying to go back to the idea of episodic memory, we should keep these kind of concepts in mind that you can analyze memory at different levels of granularity. So for instance, imagine you got invited to an Indian wedding of some kind, so you get this little invitation in the mail, And so if you've ever been to one, or at least you've been to a wedding, you could pull up a little schema, or you have a little schema about what these things might be like. So you go to the wedding, and there's like an event that takes place. This is like the henna party, which has become the new norm for a lot of these weddings. We didn't have one at our wedding, but my brother did. So, and there's going to be a little sequence of experiences within this event, and that's going to be tagged to a particular temporal context. Then you get another event, and then you get another event, and that's kind of how the wedding plays out. So you have this one broad-ranging schema under which you can kind of generate little event models, and within each of those events, you have a whole sequence of experiences. And so when you retrieve a memory, what you have to do is you have to kind of get some kind of an episode. That is, it's something that's associated with the schema, but it's tagged to a particular time and place. You don't want to just remember every wedding you've been to, but this particular wedding. And at this particular wedding, you instantiated a sequence of event models, and within each of those event models, there's sort of a sequence of experiences. And so time is a big part of this, but there's also knowledge representation. And this is something that I'll fully admit, we're just still starting, at least in my lab, I'm just starting to think about how that is. And so I really hope we can discuss that idea of what is the knowledge that kind of is the foundation for events. In our lab, or the way I think about things, I try to kind of do this sort of iterations between thinking about the brain and thinking about the representations and going back and forth and seeing if we can make some progress that way. And so our work has been kind of working from brain networks out to tasks and back. And so, everyone talks about the idea that the hippocampus is very important for episodic memory. And sometimes you hear people talk and you think that is episodic memory, right? And we know from many, many studies, and this may not be the only way of explaining it, but there's certainly a big part of the story is that the hippocampus plays a very specific role, which is at least in studies of the kind of traditional list memory that I've talked about, we know that if you show an item, let's say that people have studied, and people go, oh, I remember where and when I saw it, you'll see an increase in hippocampus activity. But if they just see the item and they go, yeah, I've seen this item before, you don't get this effect. So what we think the hippocampus is doing is allowing you to activate some kind of information about the context and some kind of information of the item, and they're both seen around the same time, and that allows you to pull up something about the episodic memory, right? But one thing that's kind of interesting is I just mentioned this idea that events aren't these particular words on a list. The time scale is very different. And so if we're seeing hippocampal activity at this micro time scale of recalling this one word from the list, where's the list, right? What's going on with that? Is the hippocampus supporting that time scale too? From the work that Janice already presented, the answer is probably not, or maybe not. And the way we've been thinking about this is, again, working back from the brain. And so we know, and basically you saw this already, is that event representation involves Cortico-Hippocampal networks. So I won't reiterate everything Janice said, but I'll just point out if you actually just take resting state data and you plug in the hippocampus as a seed, you will get the entire default network that we've talked about before. Now, the default network is a big set of regions, right? And we've done some work to try to differentiate between these regions. This is actually very new stuff. We've done older stuff where we're a little bit less we got fewer networks and now we got more. But basically in this work, we took data from 42 subjects that we got, quite a bit of resting state data. And we used these parcels from Glasser and Van Essen's parcellation of the brain. And we did what's called a community detection to identify networks in the brain from the resting state data. So when we do this, we get the canonical default network, as well as like a couple of areas in the medial temporal lobe that just want to hang out on their own. But then we said, well, okay, so the hippocampus is interacting with all these regions. Let's throw these regions into another analysis. And so we did a new community detection analysis on that set of subregions. And what we get are 3 networks. One of these networks is shown in blue, and that's we call the posterior medial network. Another is called the anterior temporal network, which is shown in red. And then a third network that we haven't talked about, and I won't talk about it for the rest of this talk, is this network that we're kind of calling the lateral network. And just in case, just to look at it, I mean, I'd love to talk to you guys about it because it looks to me like many of these areas would show up if you played people words and you had people do a verb generation task or something like that. You get auditory areas, you get the inferior frontal gyrus, et cetera. But we've focused a lot of our work on the posterior medial network, which includes retrosplenial cortex, precuneus, posterior cingulate, parahippocampal cortex, and areas in medial prefrontal cortex, and differentiated them for the perirhinal cortex and temporal pole and areas in the orbitofrontal cortex. Now that's a lot of brain areas, but we'll try to reduce the load for you. So we'll try to organize this a little bit. So we had this framework called the PMAT framework, which is before we discovered this third network, and so now unfortunately it might become PMAT-LAT, which would be pretty bad, I think. So maybe I have to do something like P-splat or something, I don't know, it's gonna be bad. But so until then, I'm gonna try to ignore the third network as much as possible. But basically the argument that we've had, and I don't have time to summarize all of this data, but we've reviewed it in 2012 and in many papers since then. I'm happy to send it to anyone who wants it. Where we argued that these two networks are interacting with the hippocampus and basically allowing you to take your experiences and strip mine it to get knowledge about different kinds of things. And the argument goes that there's this posterior medial network that we've argued to be involved in generating situation models, or in the case of event cognition, event models. And the idea is that these are mental representations of time, place, and situation that are common across different kinds of events, where the role fillers aren't very important. It's the relationships and the roles and the temporal structure that's very important. So in other words, the prediction is that these regions should do very much exactly like what Janice showed, which is generalize across cases where you have different role fillers, but the situation should be preserved. On the other hand, in the anterior temporal network, we've argued that you might get representation that's more centered around people and things. So you might get the same information in real time, but have that information split to pull out information about, like, what is this round orange thing? Oh, it's this fruit, it tastes sweet, it's good for me, you know, versus where do I find oranges when I'm in Rovereto, right? So those are two different questions, but you want both of those pieces of knowledge, and you can get both of them from one episodic memory. So what I'm going to talk about today is the idea that event cognition differentially engages the PM and the AT networks. And one of the things that's coming out of our work in other labs too is that the medial prefrontal cortex kind of popped out in our work as doing something a little bit different from both. And so I think this really nicely kind of follows up on Janice's work, which kind of focused on the whole network, because we're finding some interesting differences. And I just really want to credit Janice for her foundational work in showing, you know, she kind of was subtle about this, but this is really remarkable if you think about it, that you can average 30 seconds, 40 seconds of fMRI data into one image and average, let's say, 15 seconds of recall data. I'm probably spoiling the timescales, probably even much worse. And you can find reinstantiation of those patterns across a massive time scale from, in neural terms, I mean, that's an eternity. You know, 30 seconds is a long time. And work by Chris Baldessano on the same data set went further, and he really used data-driven methods, and this is a time point by time point pattern correlation matrix. And it's a complicated matrix, but basically what it shows is in the posterior medial network, you get these chunks where the patterns are highly, highly stable. Whereas if you look in earlier sensory areas, the patterns are much more unstable over time. This goes back to one of the questions that was asked, is how unstable are these patterns? And it really varies across brain regions. Uri Hassan's lab in general has shown this in many, many ways in many paradigms. What's interesting is that you see these abrupt shifts at boundaries between events. And this has been shown in a number of ways. So, oh, I actually put this slide back. Okay. I'll just show this. So this is work, again, from Baldessano's study, where when they identified event boundaries based on pattern shifts in the posterior medial network, what they found was at those boundaries, you see a little spike in activity in the hippocampus. So something's happening in the hippocampus when the PM network says, hey, it's time to switch, or vice versa. Maybe the hippocampus is saying it. Now, this is data from Aya Ben Yaakov, basically showing the same thing with the CAMCAN data set, which is a very large data set that was collected at Cambridge, while people watched a short movie by Alfred Hitchcock. And she replicated this finding in another study or another data set which involved watching the movie Forrest Gump. So far what we've found is that these regions seem to do interesting things at event boundaries. Zach Rea from our lab has analyzed the CamCan data with a very large number of subjects, 546. And so this is great data because we can actually say, yes, it's here. There's no replication crisis going on. So what we're finding is that the posterior hippocampus especially, which interacts the most with the posterior medial network, shows on average a very high response at event boundaries. Although as people get older and older, there's less and less of a response. And you can see that here. For young subjects, it's a very high response, but for older subjects, it's attenuated quite a bit. Now, interestingly, they didn't have a memory task on this movie, but they did get a story memory task from the Wechsler memory scale. And what Zach found is that the more posterior hippocampal activity people had at the event boundaries, the better their performance was on a completely different measure that was done outside of scanning of story memory. But if you look at list memory, you don't see these correlations. So there's something about the stories and the event boundaries that seems to be interesting for episodic memory. This is just very quick to show that the posterior medial network effects are very much like the hippocampus. That is, you get activation at event boundaries that declines with age. But you don't see this in the anterior temporal network. You don't see this in the anterior temporal network. And basically, there's almost no detectable event boundary spike period in the anterior temporal network. And the medial prefrontal cortex, actually, there is a spike at event boundaries, but the older you get, the more of a spike you get. So this is a hint that these regions are doing something different. Now, what it is, we can't say from that data set, but we're getting a hint that we're looking in the right places. And just to give you an idea, again, these are 3 different areas in the posterior medial network, and we're getting basically the same effect. So within a network, you get very preserved patterns of functional activity, but across networks, it's very different, okay? So let's go beyond the event boundary thing, though, and say what's an event in the first place, or what's in an event. And so to do this, we've had to start generating our own stimuli to basically manipulate the kinds of things that are in an event, because I like to do experiments and I can't help it, I'm a control freak, right? So in this study, Zach made his own movies with an iPhone. It's like, he's just an incredible guy. And so they're not the most interesting movies, I'll say. It's like, you probably could use a good screenwriter. But these are just movies of 2 of my postdocs basically going to the same cafe. Sorry, it's a little loud. There's not much interesting sound here. Okay, so you get the idea. This is not going to get any more interesting than this. But the way we did these movies was these 2 people are at the same place, or they could be at different places, and they're doing different actions. But the point is that we factorially crossed variables here. So we have 2 actors, which we call Tommy and Lisa. They're actually Alex and Kameen. But Tommy and Lisa could be seen in a movie in 2 different cafes or 2 different stores. So these are places in Davis, actually. But what's important is that, you know, the visuals here are kind of different, but they're both cafes. These are both stores. And so what this allowed us to do was separately look at how the brain in real time is representing information about context, about people, and about schemas that people might have. This kind of hierarchy that I've been talking about. And so the predictions we had were that if the PM network really cares about events or situation models, then it should the patterns information should reflect something about the context, but it should be fairly preserved across role fillers. And we expected the exact opposite in the anterior temporal network. And the hippocampus, if it's doing something that's specific to episodic memory, should give us event-specific information. Shockingly, the results actually came out like what I predicted for the most part. So what we do in this study is Zach was getting like 40 seconds of data. And then we basically average the entire pattern for most of these analyses across that 40 seconds. So smushing it just like Janice did. And we can look at correlations where people watch the movie for 1 time, 2nd time, and a 3rd time. So it's kind of coarse, but it gives us some kind of an idea of what kind of information is being represented. So what I'm going to show you is data for regions in the posterior medial network. And I'm going to show it to you for 2 movies that involve the same place. two movies that are in different places in different schemas, or two places that are having the same schema, but they're different exact places, okay? And they're going to involve the same character or different character. And so what we see in the posterior medial network is, in general, if you show two different movies with two different characters, but exactly the same context, you get very high pattern similarity. But if you change the context, you get lower similarity. And in many of these areas, it's kind of a graded function, so that if it's the same schema but different places, that's lower. And if they're different contexts, it's even lower. But you can see that they're generally invariant to the character information, right? Now you could say, okay, well, the places are a lot of visual information. The people are small visual information. But it turns out it doesn't seem to be that. And this goes back to Sharon's question before about, are these areas just representing more stable information or whatever? This is stable information, but it's stable information about characters in the AT network, but it's fairly invariant to the context. So what's nice about this is we're looking across the same time scale, same stimulus, and getting very different information in two different networks. And so what this is telling us is that, in fact, the brain is pulling apart this information in real time. Now, in the hippocampus, what we see is if you have the same movie repeated, you get high pattern similarity. But once you change anything, the pattern similarity drops off significantly. So this actually fit a lot with our prediction. Now I'll show you what didn't fit, or what's kind of interesting, which is the medial prefrontal cortex, so far anyway, we have actually collected all the data. This is about half the data, but we inverse p-hacked. We got a good result in the beginning, but we said we'll keep going and actually finish the whole study and see if we could destroy these results. But the effect sizes are large, and I feel good about them, so I'm showing them to you because this is like what I'm excited about right now. So basically, we see very, very high pattern similarity in the medial prefrontal cortex across both same context or same schema movies. So even though the visuals are very different here, the pattern information seems to be highly preserved relative to different movies. So it suggests that there may be a higher level of abstraction going on in the medial prefrontal cortex. Now, on one of my, sometimes I ask my postdocs to do things, and most of the time they don't do them, but they do better things sometimes. But this time I actually asked Zach to just say, let's look at the temporal dynamics within a movie. And so what I'm going to show you are data from repeating the same movie. And let's just look at pattern similarity time point by time point by time point, rather than smushing it across that 40-second period. Now, in the posterior medial cortex, so posterior cingulate, precuneus, sort of lumped together in this, what you see is as soon as you show, basically, so this is like two different movies, and then this is the same movie, so same event, context, and character, you see a pretty sustained increase in pattern similarity throughout most of the movie, and then when the movie switches, it goes back down. And when you actually see the same context but a different character, you get the same spike in pattern similarity. So again, very remarkable that something is stable across such a long period of time, and it seems fairly invariant to the characters. Now let's look at what happens in the hippocampus. So this is a much noisier signal. Your baseline pattern similarity is much lower. But what's fascinating is, look at the spike in activity at the beginning of a repetition of a movie. I mean, not activity, it's pattern similarity. So it's like you're beautifully reinstantiating this pattern at the beginning of the movie. And in fact, the spike is actually larger than the spike, right? At least numerically. But then it drops back down in the middle, and then you see a little spike at the end of the movie. When you go to a different context and different characters, so far we're not sure whether there's anything going on. So what's interesting is not only is the representational information different, but the temporal dynamics are different too in a way that really surprised me. So the next thing we asked is, again, very much like Janice's, are these patterns reinstated during recall? And the answer is yes for the most part. When we look in the posterior medial cortex, you see reinstantiation of context information. So you look at encoding retrieval similarity, recalling an event, let's say for 20 seconds versus watching the movie for 40 seconds. And even across two movies that are set in the same place, you get two movies that involve different characters, but in the same place, you get very high pattern similarity. But again, it's context sensitive. And in the perirhinal cortex, you get the character sensitivity, invariance to context. And in the medial prefrontal cortex, we see, again, this generalization across these two schema-consistent contexts, but relative to different contexts. And so far, shockingly, we're seeing no evidence of reinstatement in the hippocampus. So this is, again, something that I think is very important about studying these complex events, is if you study these little thin slices of experience, the hippocampus comes out all over the place. But once you start to stretch out the time scale, things get a little distorted. Now, I want to be clear, actually, Christian Dohler's lab's done many great studies on these kinds of stimuli, and he does get reinstantiation effects in the hippocampus. And my guess is we probably have to look at that finer time scale and factor in some of the idiosyncrasies across people to see better results there. But the important thing is that the neocortex is doing a lot of heavy lifting. So I've told you so far the PM network tracks information about context. The medial prefrontal cortex seems to be tracking information about situations, and the anterior temporal network seems to be tracking information about people, and the hippocampus seems to be putting all this stuff together, people, situations at a particular context. And finally, we're not seeing any boundary effects in the anterior temporal network, but we do see this people information, suggesting, again, events are being parsed by the brain in different ways that are actually also supporting recall. So the next thing I want to get at is what happens over time, because in memory research, we usually, because it's really easy and convenient, we study people, we test people immediately after they study the information. We say that's long-term memory. But of course, we remember information over time, and as I said, Bartlett showed that as people remember these events over and over, they change. They become shorter, and they become more coherent with each other. And actually, this is an idea that I've really liked. A lot of people talk about memory consolidation, this idea that somehow over time something happens to memories to allow them to become more stable. I've never liked this idea per se, but I do believe something happens, and Morris Moscovich has advocated for this idea, and others have too, that maybe something is being transformed in memory. And Penny Lewis proposed this idea that actually information might become integrated over the course of consolidation, especially with sleep. So let's go back to this idea about events and memory. So Jeff Sachs' event segmentation theory has argued when you go and you hit an event boundary, you sort of flush your mental model, and you start a new event, and you start a new event, right? And memory research has shown that these boundaries have very real effects on memory. So it's just like when you walk through a doorway, for instance, people have found that whatever you're doing right before you cross the doorway, you have trouble remembering it. And we've all had this experience, I hope. As you get older, it gets more common where you walk into another room to try to get something, and by the time you got there, you have no idea what you were looking for. So this happens in real time. But somehow we also remember events that transcend event boundaries. And so in episodic memory, you might have an episode that involves multiple events, and you link them together. So how does this happen? And so the hypothesis that we've had is that the hippocampus likes to organize things according to time. So you lump a bunch of experiences according to temporal context, you hit an event boundary, and you may get remapping of the hippocampus. But it wants to organize experience over time. And forgive me for being overly simplistic. But interestingly, during slow wave sleep or during offline states, even during rest, you get reactivation events where sequences of place cells, not individual place cells, but sequences of place cells are reactivated in the hippocampus. And it's thought that this may be a way of kind of teaching the cortex, or at least by virtue of connectivity with the cortex, that you may be seeing something that's happening in the cortex through this repeated reactivation of these sequences of experience. But it's not necessarily the case that these sequences are being replayed in the same order that the events occurred in, right? So imagine you take a bunch of temporally sequenced experiences and you shuffle around the reactivation events. Now the network is not going to be stuck in terms of the temporal dependencies of experience. Now it can start to pull out things that may be structure in the world as opposed to structure in time. And so that's the idea that we've had, is that memories might become more organized by event structure over time. Now, just as a starting point for this, we had this idea, and Brendan Conchi, an MD PhD student in my lab, actually did the heavy lifting for this. He came up with a paradigm to try to test this idea. And so what we did was we created stories that involve a main protagonist. And so we call this the Kramer paradigm, because if you ever watch an episode of Seinfeld, for those of you who are old enough, what you'll find is that there's a story that involves Jerry, but periodically Kramer will fall into the room and something will happen, and then 5 minutes later something else happens with Kramer. And so that's what we tried to do, is we embedded these stories with side plots that involved a character who's repeated, but the story is a little bit of a diversion from the main story. And some of these side plots come together. So for instance, these would be presented in two different stories, but in one character, basically one story the character says, I left my oven on and can't find my keys. And then in the next story, the character talks to a different protagonist and says, luckily the fire department has a spare key. And so you can guess that what happened was that the place was set on fire. On the other hand, we also had incoherent side plots where effectively the character shows up in two different stories, but the two stories don't fit into a larger narrative. They're just separate from each other. And so the idea is that as you're listening to these stories, you hear these little side plots where these characters come in. And it's the same character for the red and the same character for the blue. But in the blue case, when you're hearing this part of the story, you're probably referring back to the earlier story to make sense of what happened. Or at least you could be. And so the idea is that that process of being able to integrate these things, even though by almost any theory they're separated in time, they're separated in events, they shouldn't be integrated. We have this feeling that they should be, right? And so to look at the effect of consolidation in this first study, we tested people immediately or 1 day later. How am I doing on time? Oh, good. I'm fine then. Okay. So what we actually found, and I was surprised by this, we found, so first of all, I'll just say that the way we had to come up with some scoring criteria for this from these narratives, and so we got RAs trained. They had a very reliable scoring protocol, very hard work. Again, Janice was very modest when she was talking about her stuff, but it's ridiculously hard to come up with these paradigms and these scoring protocols. That's why nobody does it. It's because it's hard. So we did this, and then basically what Brendan did was he said, okay, let's look at the number of details where people report where we can verify that they're part of the story. We're sure of it. And so with this protocol, we get the main number of verifiable details that people recalled immediately did not differ across coherent and incoherent narratives. But 24 hours later, a different group of subjects shows a dramatic enhancement of recall of coherent narratives relative to incoherent narratives. Now, these are different groups of subjects, but what's fascinating is the recall seems to be higher at a 24-hour delay, which I've never seen in any study of episodic memory that I know of, and certainly in my own experience. Now, this may be a little bit of a quirk, but I'll show you some other data, at least that the basic effect that happens later is a real effect. So my RA Angelique De La Rosa in the lab, she's working on 5 different studies, but she comes up to me and she says, do you have an experiment that I can do and I can take charge of? And so I said, well, I've been talking to Brendan about seeing whether that effect depends on sleep. And she just made it happen. And so she ran this study. We're still not through all the subjects because coding these data takes so long. But we have 18 per group. And she basically made plots specifically for this talk. And so interestingly, the effects are there, in this smaller group, but it's biggest for the details from the first story. So if you look at the details for the first story, what you see is that if people have a 12-hour delay, but they study in the evening and they're tested the next morning, you see a dramatic increase in memory for coherent narratives relative to incoherent narratives. But if they get no sleep, they're low for both. And so the effect, again, seems to be dependent on consolidation, seems to be driven by sleep, which is pretty interesting. So let me backtrack now and just say, the punchline to all this is that, we're studying complex events for a reason, because that's how we remember. And it turns out studying memory at that scale actually tells us a lot about how we remember in ways that at least were counterintuitive to me. And I think within the brain, we're starting to see, a lot of people would say when people recollect events, you get parietal activation, you get hippocampal activation. But when we actually look at this longer time scale and we start to manipulate the variables that people remember, we can pull apart this information in really interesting ways. And one of the interesting things that's coming out of this is the ventromedial prefrontal cortex, which functionally interacts with the hippocampus and with the posterior medial network, seems to be doing something that's a little bit more general than events, and it seems to be doing something about classes of events. So, and then finally, there's this idea that events may be organized in time, but through sleep and through consolidation, we may be able to build up information that integrates across events, and that may be how we develop event schemas in the first place. So eventually we'll start looking at that. So finally, so this is just a picture summarizing what I was talking about, which is there's this hierarchy of information within an event. You might have people going back and forth, and you have events, and you have schemas. And effectively, we can map this on roughly to different brain regions and different brain networks. And I just want to say that we're working right now with, through a big team that it's kind of like these are the super friends, so to speak. And I guess I feel like kind of Robin relative to Batman in this group. But nonetheless, I'm PI of this project. But Sam Gershman, Lucia Maloney, Ken Norman, Jeff Sachs, and me are working on this project. And Sam's postdoc, Nick, basically developed a computational framework called structured event memory to try to explain this. And what's the interesting thing, I think, relative to this group is he basically instantiates, well, there's a whole thing about being able to separate agents and relationships and so forth in a connectionist model that's very cool in and of itself. But also, he models event schemas through recurrent neural networks that are basically designed to predict the future. So the networks train themselves based on the world. And so as a result, whatever's happening in the current state is eventually going to be able to predict states that are happening way down the road. And so this fits with this idea of the PM network carrying information at long time scales, and it fits with this idea of event segmentation theory. If you have these mental representations that are going to be maintained for long periods of time and then abruptly switched when you have failures. And the way we're modeling that is in terms of the ventromedial PFC, allowing you to flip between different schemas that are instantiated in different networks. And we're working with Randy O'Reilly, who's coming to UC Davis in the fall, by the way, on computational modeling that will help us understand and even make some new predictions about the memory consolidation work that I showed you. So at that point, I just want to thank you and especially thank the people who did this work, and I'm really happy to discuss this for another half hour. Christian, or I don't know, should I take the questions or should you should, right? Yeah, you talk. Oh, Alex, okay.
No, this is just an...
You didn't stand up and clap, Alex. I know it blew it.
I promised him a standing ovation, so...
Did not get it.
No, this is
Next
just...
time. Oh. Oh, that's right, okay. Is this... There we go. Am I okay now? So I shouldn't do this, right? Okay.
So this is just a question, just for information's sake.
Okay.
What were you trying to say about the hippocampus? You seem to make a lot of claims. It seems to be central to all this. And so what is the role of the hippocampus?
Damn you, Martin. It's an incomplete story. I mean, we know from many studies that people like Christian and I have done, many others in this room, I don't want to actually leave out anyone, but that the hippocampus is activated reliably when people go, I can remember this event, I can re-experience it, blah, blah, blah. And pattern information is preserved in many cases across two events that occurred in the same place, but especially two experiences that were in the same temporal context. So that part... Well, so we've done one study on this topic, which kind of ended up, unfortunately, instead of being forgotten after we published it. But we did a study looking at memory 24 hours later versus immediate testing. And so we looked at whether two words, let's say, that were encoded within the same kind of encoding question would be showing some pattern information that's reinstantiated during test, and that in the hippocampus. So if you test immediately, we see beautiful pattern reinstantiation for context reinstatement for recollected items. If you look 24 hours later, it was just kind of, It was not one of those things that made it go, it's not there, nor was it there. But then when we looked at the people's performance on the context memory task, people who showed good context memory showed the reinstatement. People who showed poor context memory didn't. So my thinking is very much like Morris's, that if you have the contextual information, then the hippocampus is still playing a role. Now, should I just sit down there? And then? Yeah, sure, okay. I should sample this for one of my records. Oh, okay. How about now? Okay. So, so what I'll say about this is yes, with a caveat, which is with these complex events, one of the things we're finding is beginnings and endings are special. And Aya Ben Yaakov really deserves some credit. You saw her poster for pointing this out. And it may well be the case that you can get a lot of contextual information for free from the posterior medial network, but it might be more schematized without a hippocampus. And so what you'd lose is not necessarily contextual information, but detail that's specific to that place and time. And maybe the re-experience. I don't know. I don't study consciousness, but.
Hi. So now I have the microphone. So you were reviewing the literature on event boundaries at the beginning of your talk, and you show sort of consistent findings that the posterior network peaks when there is an event boundary or signals the presence of an event boundary. The posterior network is probably more visually driven than the anterior network. Has anybody tested the idea that that could be just a simple or more simple visually driven effect rather than really the detection of the meaning of an event boundary?
Yeah, that's a great question. In Zach's aging analysis on the 546 subjects, we ran a first pass at doing that. He basically tracked what he calls visual flow. And don't ask me what visual flow exactly is, but he was basically tracking I think he was tracking the change in visual information over time. And basically you get exactly what you should get in the pattern information, which is pattern information that correlates with extrastriate visual cortex and other visual stuff that you guys know way more about than I do, but it stops around the PM network. So the PM network didn't show that effect significantly. Now, does that mean it never is sensitive to visual information? I wouldn't say that. But clearly the fact that you get this, the effects that Janice gets and what we get and what Chris Baldessano gets, it generalizes across even modalities, in a way that seems like it's much more than, so I would guess that when you recall something, you might have a feedback, like actually a lot of memory binding, so to speak, may be done at the level of the PM network and may feed back to these scene processing areas. But it's not necessarily being driven by the visual input.
There's a hand right there.
Hi, thanks so much for a great talk. I just love the coherent, incoherent side plot story. I think those data are amazing. And I'm kind of putting it together with what Alex was saying, and I was wondering what is underlying that really incredible boost that's happening after sleep, and what is being transformed, and is it something maybe counterintuitive where, well, I guess I don't know what the stories are, but could it be perhaps, so you have this character that's in different, presumably in different contexts. That's right. And so the manner in which they're integrated is the fact that this like hippocampal information is actually lost. That it's like kind of like the loss of this hippocampalness that enables that exact.
Well, yeah, it's a great question, and it very well could be. We're running the fMRI study now, so we can start to look at this. But I don't feel good enough, this is about the data to show the preliminary data for this yet. What I can say is that even, the standard systems consolidation model is that, the hippocampus teaches the cortex, so to speak, which I would say is the PM network, and that basically that would then lead the hippocampus to kind of drop out. To me, it's perfectly reasonable to think that you could have both representations, that you can have a schema representation or an event representation that generalizes across contexts. But if you pattern complete in the hippocampus, you suppress those competing, information. You get the event-specific information in PM network. So to me, it's not mutually exclusive, but there may also be, one of the things, there's a lot about replay that people assume that we just don't know. What determines which memories are replayed? What determines, it's probably not a one-directional flow. That is, there's probably information that feeds back to the hippocampus. At least I've heard some researchers talk about this. And if so, what you may be seeing is a transformation in the hippocampus as well. So I think all bets are off. I don't have a good answer to that.
I wonder if there's any clues in the narratives. I mean, I know how hard it is to do this sort of scoring, but if you've looked to see like the nature of those details and, I don't know, just an idea.
Yeah, no, this is, well, so in these data, we haven't yet gotten that. And a postdoc of mine, Alex Barnett, is doing a study to look at this where he actually made his own animated films. I mean, actually, I saw the first teaser of it, and I'm dying to see the whole thing, but I just haven't had time. But it's like Shrek, you know. It's just like you can't take your eyes off it. And so he's having people recall one movie at a short delay and one movie at a long delay. What he's seeing very, very subjectively from inspecting the recall data, and we're still trying to figure out the best way to do it analytically, and I'd love to get everyone's feedback on this, is that he's seeing that people recall the events out of order as the events get older. So maybe that is going along with a change in the hippocampus. That, you know, so what Janice showed about this beautiful sequential recall, that there's less of it and people get more character-centered and less, you know, so they'll kind of go, oh, this person was doing this, this, and this, and this person was doing this, this, and that. This is still very subjective, but I think that it's totally we can get at this.
Charan was next.
So you expressed with great glee and surprise the improvement in memory after sleep. Actually see an improvement saying this, you know, you never see improvements with more time. But in domains outside of events, there's lots of published examples of improvements after sleep. So other things people tend to think about the hippocampus caring about, like space. So Mark Kutanch in the back has published data showing that you get improvements in memory about sort of inferred spatial locations after sleep. There's been similar rodent work showing improvements in understanding the spatial sort of schema or gist. So again, it was space and not time. And then even in domains where you don't even think of it as anything to do with the hippocampus at all, so like word learning, you see what looks like integration into lexical phonological networks that is revealed
like Gareth Gaskell's
exactly
stuff.
After sleep. So there's lots and lots of examples. So I guess I'm wondering whether your surprise is that you didn't think this would happen in the domain of time, or is there something?
I said again, I don't know what I did.
Is there something you think is special about reorganizing information that has to do with time, that you were surprised about the time piece specifically, given that you know all these other data about spatial consolidation and lexical consolidation, or was it just you're always happy to see things that make sense, right?
Well, so it was a very long question, but I think that, so let me make sure I understand.
Well, if you go to sleep, then when you wake up, you'll know the question better.
Why are you surprised, Ranganath? That's the question. And so I'll say that it is true that you do get these improvements in certain things. And I get, so part of me is like, there are some artifacts that go into it. Like if you look at motor learning, for instance, you average over a 1 hour session and then you look at the next hour session. It makes it look like there's more of an improvement than there is. And if you actually plot the learning curves, it's more continuous. But I absolutely agree that there do seem to be some qualitative changes. And that prompted our looking at this integration idea. So it's not that. The thing that I found counterintuitive, and I want to see it many, many times, is nobody subjectively says, I remember something better a week later than I did it originally, especially for something as arbitrary as a story. I mean, if you were to read a book, I doubt that you could recall as many details from it, a week later than, and actually, here's the other part of it. I didn't say this. So when we look at the main plots, the main protagonist, you don't see this effect. It's really specific to the coherent side plot. So this does go along with what you're saying, and when we looked at that data, I was like, okay, this starts to make sense, because one day later you wouldn't expect necessarily to remember everything better, right. But it's exactly the kind of thing that you get. So yeah, maybe I'm a little more thick than you. It took me longer to believe it, but it's eventually we came around.
There were a couple of hands at the back there, I think. Other questions over on this side? I think Jerry and then. Jerry first, I think he was first and then.
This is great, because I wanted to start my question by saying I wanted to put words in Alfonso's mouth. And the words would go something like this. By the way, I loved it, so don't take this as any kind of critical thing.
I'm a big boy, I can handle it.
In a sense, what you've shown us is a...
I don't know if I can handle Carmanzo's question.
It's like, yeah, I can't ask it with a forcefulness, but in a sense what we have is a map that shows us where the stores are and where some of the roads are, but it doesn't tell us how the stores are actually doing their work. And let me give a specific example and then ask a very specific question. So very early on you put up a picture from one of actually your review papers where, I can't remember, Hippocampal complex is doing context and Prefrontal is doing the object.
Item information, yeah.
So what is controlling what at any moment in time is the object and which is the context? Because if I'm in the cafe and I now get spray paint and I spray over the wall, the context becomes the object.
Yeah.
How and a lot of the events that people talk about, a lot of the events that people go off, like Jeff and the Reynolds study with SRNs, there's a single agent and there's maybe an object, maybe not. What is doing that control? I mean, people like Charan care about control and selecting between things, and LIFG is implicated there. What is controlling this within these networks?
Yeah, so let me address the second part of your question, then go back to the first part. I'll just say very quickly, we talk about these naturalistic memory paradigms, but there's a big element missing, which is control, right? So we are physically interacting with the world. We have goals and we have intentions. That's all thrown out the window in the movie stuff, right? It's like this is very passively received and we're trying to make sense of it. It's not, it's very different making sense of a spatial map when you're driving versus when you're a passenger, and this has been shown in many ways. So we can't say much about that part of it. Getting back to the other part, you brought this up earlier, I think, in your question about figure ground segregation. I think that's a very good analogy, because if I were to ask you, what determines what's figure and what's ground, right? You'd have to go, well, a bunch of things, There's no one thing, right? And I think the answer is very similar for spatial, for context and item information. So for instance, contexts tend to be big. They tend to contain things. They tend to be slowly changing. In other words, I look around, I look back, the borders are pretty much looking like they were before. Things are much more dynamic. They can move in different ways. Rooms contain people. People don't contain rooms. We tend to, like right now, I'm attending to you and I'm backgrounding the room. I'm backgrounding the situation, and so my attention is focused on you. And so I think scale and attentional focus are big parts of it. And so that's kind of my answer to that part of the question.
I'm embarrassed to say my question is similar to Jerry's.
He took the words out of your mouth.
I mean, I wish I had a chance to ask it first. But anyway, I wouldn't frame it in terms of control, but I mean, the thing I liked about your presentation was the scope. I mean, it's amazing, sort of trying to bring all these things together. And I've always sort of had this, if I understood what he was saying, this problem of how it is that variables are filled in. So how variables are filled in. So I have a representation that involves relations of some sort, and then I have to fill it in as Tom and as Mary. Okay, so and your belief that, or the claim that these things are represented in different parts of the brain, and so they have to be in some way coordinated. Okay, and so where does this coordination come from? Is it that, how do I know that it is Mary that fills this variable, and not Tom?
Yeah, the binding problem.
So you have so in representation X, we have just a variable. This may explain why you get these generalizations, because it's a variable, it's not a particular element. Okay, but how is this coordination performed? And is my feeling of, oh, Mary did this, the co-occurrence of all of these things happening at the same time? That's scary, because then how do we get all of these things happening at the same time result in a single representation that I can articulate in telling you a story?
Yeah.
Where in this representational scheme do these things come together?
Okay, no, that's a fantastic question. It's like the ultimate binding problem, right? And I think Mel has probably answered this question for vision, so I might actually have a bad answer relative to that. But my answer is going to be that in some situations we might feel like we are binding those things, but we're actually focusing on one or the other. So for instance, when you drive, this is just totally stream of consciousness here, but my sense is when you're driving, you're not really focusing typically on any one person or any one object. You might have the feeling that you are, but really often you're just checking things against a mental model of where you are, and it's often not even literally looking so much as verifying, right? And you can see this in eye movements, for instance. People tend to make predictive saccades, and especially when they're watching movies, for instance. So in many cases, there may be a subjective illusion of binding that's not really there. But also, and when I talk about this, I mean very high-level representations. So I'm not necessarily saying that people don't literally see the objects, but I'm talking about like being able to relate a visual form to another visual form that's completely different, to a spoken word, to, like the kind of stuff Lolly Tyler does, for instance. And that clearly seems to be dependent in part, I think, on perirhinal cortex. So, in certain situations, sure, we may be trying to link an online representation of the situation with an online representation that's a deep conceptual representation of the items. I think many times you're not, but maybe when you are, I'll just throw the answer to the prefrontal cortex. I'll just say that's where it's happening.
But on that story, you shouldn't be surprised. On that story, then why is it that you're surprised when it's not Mary but John?
Sorry, say that again?
On the story that, in fact, there's the illusion of having a unit representation, then there should be no surprise. So if all of a sudden I tell you, it wasn't Mary, it was John, where did the illusion come from? In other words, there is, in fact, there has to be continuous binding for there to be surprise.
Oh, there has to be, So there is a binding, and I'll just make this argument since I think you're okay with my making an argument based on no facts. Because I don't mean that came out totally wrong, but I meant that in terms of my lack of knowledge, and I think you're pushing me to speculate. That's what I meant. Ignore anything else. So if I were to speculate, what I would say is that you are, even to make an event model, you have to fill these roles, right? In other words, it's not like you're getting no information about the role fillers, but it's a fairly, it's not a filler-centered representation. So you can imagine you get more transfer amongst two symposia events that involve different people than two Alfonso events that involve different situations in the PM network. So there is some information there, and definitely the visual information will be different, right? And that could be enough to trigger a prediction error or just trigger a change that, creates a new attractor state, say, in the PM network. So I don't want to, and there's other possibilities too, which is we're looking at a very, very coarse time scale. And perhaps if we had, multi-unit recordings and local field potentials and millisecond time scales, we would see these kind of oscillatory interactions or something and thalamic binding, blah, blah, blah. So
I'll relinquish the mic when you tell me if there's someone who wants to ask a question. But still, so I think you've said, if I understood what you just said, is that in fact, at any instant in time, the whole network is coherently organized. That is, everything is filled in at any moment in time. And so the binding is actually going on continuously. And so the question then becomes, given that you've separated these representations over different parts of the brain, how does it occur? So they can only be surprised if there's binding, right? And given that it is occurring over time continuously, then do we have a story? I think it's fantastic. This is not a criticism. This is a question of do we have a story of how it is that I can have this unitary representation of the world at any moment in time occurring over all these different areas?
Well, like I said, this is all speculative, but I'm going to go to the mat on this illusion part and just try it out and see if it sticks. So basically, I think we have to be careful when we're talking about the binding of the representation, because what is the representation in the first place? So you can get a lot of object information without a perirhinal cortex, right? It's not like you damage the perirhinal cortex and people become completely agnosic. It's a more interesting kind of, even in semantic dementia, they're processing a lot of information about the objects, right? And that ravages the whole AT network. So my kind of argument, and I realize I'm totally outgunned here when I'm talking about this, is that you're not necessarily getting a representation that's bound at the level of the AT and the PM networks. It may be that you flash between them, or it may be that you are sometimes engaging them concurrently, but many times in many tests you prioritize one network and you're getting some Alfonso information. But the way I think about these as a memory researcher, I think about it in terms of, let's say, libraries, right? So you could file your books according to the author or when they were published or some combination thereof, right? And so I think you could get the same information about the author in the perirhinal cortex, in the AT network, and the PM network. But the organizational scheme in the PM network would be more about like the topic, fiction, nonfiction, murder mysteries, et cetera. Or the kind of the situation, so to speak. And in the PM network, AT network would be more about the author, so to speak. And the hippocampus, it's about when it was published. So there's still information that's shared across those representations. And you could still have a sense that I'm processing the Alfonso information while I'm maintaining this conversation. But maybe what I do is I flip back to, what do I think Alfonso's like? Can I trust him to let me speculate? And then I go back to my mental model and I populate that, and then I start to make inferences. And these are tough questions, right? And to get brain data on this in real time across a long time scale like that, it's a ridiculously hard problem. So, but what my answer is probably that you do different kinds of binding depending on what people are doing, and that there may be at any given time a lot more separation and prioritization of some kinds of mental representations than we are aware of, because we're looking at we're using the information in a particular way. So part of the representation is how we're using it, if that makes any sense.
So it is very interesting. So one prediction be then that you could get associations where someone can tell you Mary and John were there, definitely. I have no idea what they were doing. I have no idea who did what, when, okay? All I know is that Mary and John were there.
Yeah,
okay?
yeah.
So you would predict then, or perhaps someone would predict, that damaging I forget the labels, which particular one it was. Okay, so this would be an interesting prediction to see if it holds up. So I don't know enough.
This is why I've really gotten into aging and dementia research, because one of the things that I really inspired us with the PMAT framework was looking into the early Alzheimer's literature, looking at semantic dementia literature. Hippocampus is hit in both. Perirhinal cortex is hit in both, parahippocampal cortex a little bit, but you get this massive distinction between loss of what people think of as episodic memory and spatial information versus loss of information about the meaning of people and things, right? And in the episodic memory literature, people say, oh, you lesion the parietal cortex and people remember events just fine. But that's, if you think about the network as a fully connected network, you still have so much ability to reorganize because you're not losing a linking node, whereas I think in amnesia, you lose these nodes that allow you to communicate between the networks. So getting back to this, I do predict that, and I'm hoping we can test it, that if you have enough damage that is disproportionate enough to one of the networks, so you select the right patients, you should be able to see this deficit.
We have time for one quick question, one last question, if someone has a last comment. No? In that case, let's thank the speaker.
All right, so at this point, I want to invite the two who aren't already on the stage back up to the stage. As advertised, the plan now is to have about a 30-minute time for a general discussion. Hopefully you guys took your homework assignment seriously and have been looking for broad questions that go beyond what any one particular speaker might have something to say about that we could address to 2 or more of the speakers up here. While you're thinking up those questions, I wanted to kick things off, and I've given them some advance warning about the first question I wanted to throw at them, which is I gave each of them a little homework assignment, which was to try and share with us something that they heard today in one of the 3 talks outside of their own that they think connects to the work that's ongoing in their own group. So to help us kind of stitch this together a little bit. So maybe we'll start down at the end with Anna had the most time to think about this.
Yes, that's right. And I had the most time to think about the first 2 speakers, so I will raise a couple of themes that connect to some of the infancy work and some of the work that Janice brought up. So one sort of idea that I had is, trying to connect some of the infant role data to some of the things we see in language and elsewhere about roles. And I guess the question that I had for Gergo is, how do you see this approach to, let's say, the giving event, generalized to a whole host of event roles, right, that we see in both language and presumably cognition? And what sort of possible asymmetries might we find? Are all roles born equal? And just to give you time to think about this, right? So my question to Janice would be, I could see a lot of potential for a very fine-grained analysis of your lovely linguistic data, right? And of course, as a language person, I was very inspired by that. And there's a lot of this value in doing this, taking this perspective that zooms out from the specifics, but there's also value in zooming in. So I know you mentioned, there are some events that appear to be more interconnected to what's happening compared to others. And I was wondering, of course, you can see this interconnectivity just by looking, from the outside within into these networks. But I was thinking, if you look at these things from within, what do we know about these, what kind of event is actually, or sub-event is the one that appears to be more interconnected than others? What are their properties? Are they causal? What can we infer about them? And what role do they play in how we stitch together events into longer units?
Did you want them to try and answer those questions now, or you're just throwing them out for them to think about? Or? All right, well, maybe we'll sweep down the line and hear, just from each of you, and then we can circle back to some of those things. Charan?
So I mean, this has been both in the outside conversations and watching the speakers. It's just been, I'm learning a lot, and so in my jet lag brain, I haven't integrated it fully yet. But
it'll happen tomorrow.
Do I not? Is this thing on?
After sleep.
Yeah. Okay. So sorry about that. But I think one thing that really stuck with me was thinking about Anna's work and trying to relate it to my own, because I don't think about language very much. But one of the things I like with yeah, exactly. Just like you're thinking about episodic memory. So, one of the things that struck me was you did this beautiful demonstration of just showing people a picture, and that was enough to get a little event model in people's heads. And this is really important because a lot of people will go, oh, look, we showed this picture, and you can get this effect, and therefore this region is doing something that's happening at a very, that's something specific to the picture properties, right? The visual aspects of the picture. I think what that nicely showed is that there's something bigger than that we generate on the fly to make sense of this stuff. And I was also interested in this idea of bounded versus unbounded events, and kind of the idea that one of the things that's implicated in a bounded event is that there's a sequence that's implicit to the meaning of a bounded event, right? So if I'm peeling an orange or something like that, there's a sequence of grabbing this and then peeling and then putting it down, or I don't know, something like that, right? And so Sharon's postdoc, who's going to be working with me, Anna Leshinskaya, is really interested in this idea of how sequential information is used to build concepts. And the idea, like for instance, a coffee maker only has meaning in the sense that through the fact that you put coffee in it, you put water in it, and then you get coffee out. But to really understand it in her view, you have to have that sequential information. And so there may be an interesting interaction between the hippocampus and neocortical regions in terms of doing that.
bounded and unbounded events, and thinking about the details of the linguistic data that we collect, because we've only begun to analyze it in a very difficult but also coarse way. And I actually was talking to Lisa earlier about maybe doing the analysis where we go in and ask, what are people saying about these events? Do they tend to describe them in a bounded or an unbounded manner? And I guess I would ask your prediction about that. I think my guess is because they're trying to deliver information in a compact way, they mostly use bounded descriptions, but that probably also interacts with what's actually being shown. And maybe an interesting thing to pursue would be when, like in some of the videos you showed, the event doesn't complete, but you can infer that the ending is coming. And whether when people have the opportunity to complete that event, if it isn't fully shown from the original, they actually experience more transformation of their memory. So thoughts on that would be really useful for me. And I don't know if this is cheating, but I'm very interested to hear any thoughts you have related to the function of episodic memory as a communication, as a communicative act, because I mentioned it in my talk, but I really feel that the communication aspect of this kind of recall makes it what it is. It's different kind of memory behavior than I've studied before. So if you have thoughts about what you would do if you were doing it, I would hear them.
Okay, so this is a question to everyone. Practically, the question is, what is an event, right? So I was invited here to this symposium about events, and I thought that I'd work on how people, mainly very young people, interpret actions. Actions are events, so let's talk about actions, right? But I think that the idea of event is much broader, right? So I expected that people will talk about other types of events, but it turns out that everyone talks about actions when we talk about events, actions or action chains or side plots or stories or narratives, which are all involve people who actually perform things in the world, which is very interesting because obviously there are other kinds of events. I mean, so there are natural events, storms, earthquakes, sunsets, even events that involve people, like you get a stroke, you sleep, whatever. These are events that have boundaries and so on. But we just forget them when we talk about events, and this is interesting actually from a point of view that even the researchers are biased in terms of what they think. So I'm interested whether, because it seems that you talk about how our memory is structured in terms of temporal and causal and various kinds of ways. But those are actually structured by what we think about actions and social interactions, right? So it's not necessarily temporal. Temporal is just one aspect of the social interactions because our life unfolds in the temporal domain. So I'm not sure whether what we learned today could be meaningfully extended outside actions, and if not, then why just we talk about actions and not general events?
Great, so a bunch of questions just got put on the table. Before I open things up, did anyone want to respond to any particular question they were just asked?
I'll just say something real quick, just, you can put the organizer's hat on and just say, this is exactly why we had this idea of putting this together, precisely because you see people who come obviously from very different backgrounds, start converging and, start thinking about things that, connect to a lot of these, theories. Just to say something about the scope of what it is we're all studying, I think the last question, I actually expected somebody to ask, at the outset, what is an event? What are we here for? What are we studying, right? And so the technical definition of an event, at least in my world, is a change of state, right? So something needs to change to have an event. Most people, going back, this is basically the bounded events, right? These are canonical things that have boundaries. As far as I know, most people who have studied events, Jeff Sachs included, all of his work, a lot of the infant work, looks at this kind of event. There's other things that don't fall in this class, so you have a lot of these, unbounded continuous events that are basically activities, right? They are sort of slightly deficient as events, so walking, for instance, is not technically an event. Walking to a store is an event. right? Walking is an activity, sort of this unbounded event. But of course, you can't build, I call them both events, right? Different names. You can't build, I think, a theory of events, technically speaking, right? Changes of states, unless you have a theory about other things that are similar, like activities, right? And so you can't have a theory about what it is to remember walking to a store without having a theory about what walking is, right? And so in some sense, we're all being a little imperialistic and we're covering sort of more ground and going beyond what would be sort of a canonical unit to have a fuller sort of representation of what's out there. And just one last point, you're right that we all focused on concrete, observable things, right, that can be depicted in cute movies and videos, right? But an act of decision is an event, right? So decide is an event,
right.
And think is an activity. So it's like stuff again, sort of an unbounded. And there's actually interesting work that shows that, again, using language, that partly linguistic stimuli and partly sort of novel science, that people can derive these generalizations such that they connect a sign for something continuous to an event like think, and a sign that corresponds to something discrete to something like design, right? So there is a notion, an event-related notion that unites these things across the concrete and the abstract. But it's a very interesting question, how do we build these more abstract representations? What are they made of?
All right, Brad, you have a question too? Can you get you this microphone, maybe?
Pass the mic.
Thank you. So in the domain of space, I think it's well established that space is not represented monolithically, right? So there's distinctions between allocentric coordinates, egocentric coordinates, different systems engage with space on their own terms, sort of. And everybody, and time is maybe one of the horizons that unites all of the talks today. But I haven't really heard anybody address whether or not time is instantiated differently in different systems that are that are interacting or processing events in different ways. Phenomenologically, it feels like sometimes time dilates and things slow down, right? If you're in a traumatic situation, it seems like you take in a lot more information in a short amount of time. Sometimes it speeds up and it flies by. So I'm just wondering if time scales is something that you've thought about, and whether or not the different kinds of neural systems that you've been discussing might instantiate time in different ways, and how should we think about that?
The work that Charan and I both mentioned, and Charan actually showed a figure from Chris Balosano's paper. So this is kind of actually combining these last two statements, that if we take the definition of an event and an event boundary as a change in state, and we treat the neural pattern changes as those event boundaries, then you can look across the entire brain during a continuous stimulus and just ask, where do we see those event boundaries in every part of the brain? And what you see is that there are faster event changes in sensory cortices, and as you move up the cortical hierarchy, those event boundaries come further and further apart. And it's partly because of the intrinsic fluctuation timescales of those different areas, but it actually does align with what people will say as well. So at the very highest levels in your default network, the event boundaries as defined by the sudden shifts of the pattern correspond reasonably well to if you ask people where they would put those event boundaries in the movie. And it hasn't been done yet, but I think it needs to be done soon, to just ask people to segment things in a finer time scale, which they can definitely do.
You mean in the scanner, because it's been done behaviorally?
But matched to the boundaries that are measured from the fMRI data too. And like the prediction is pretty clear that like you have your small boundaries in lower sensory regions that should be nested within the coarser boundaries of the next region up, and then the highest level corresponds to what people usually say when they talk about event boundaries. But that hasn't been done yet. Maybe you want to follow.
Yeah, I mean, that was a great answer, and I think it relates actually to where you started from too. So, so first of all, I think time and schemas are very hot, and these are all things that get abused in different ways too. And so it really helps to have theories about what these things actually are, because you can have time, for instance, in sequences where it's an ordinal representation, or you can have time in terms of like you're talking about time dilation, where it's more of an interval timing. And so I won't speak to that any further, but just to say, I think scale is very important. This goes back to your comment about, like giving versus like, a narrative, for instance. And I think this hierarchical kind of way of we experience things is a very meaningful thing, right? And actually, it's interesting that you brought up space too, because again, I'm just going to throw this out there, and you guys could throw it back at me. But my understanding is like when people have looked at, let's say, the ventral stream, what you find is the medial stream that's more involved in scene processing also responds to more peripheral information, and the more lateral stream responds to more foveal information. So even there, you're getting kind of a pulling apart of scales, but it's a spatial scale. Although, really, to even many cases, when we're pulling in scene information, we're making broad eye movements and integrating across a broader period of time than we are with a foveal thing where I can grab your face with not having to move in a lot amount of time. So there may be even correlations there too. So my suspicion is that spatial and temporal scales are involved, and I think thinking about time scales in terms of rate of change in neural states is probably a good way of thinking about it, because you can imagine, like you said, you get emotionally aroused. Maybe neuromodulators change the rate of, the rate of change speeds up or it slows down depending on, emotional states, for instance. And so that may be how we need to think about it.
Hi. So going back to this definition of an event being a change in state, one sort of commonality I saw across your talks is you're looking at participants observing changes in state, but in a way they might not necessarily be experiencing a change in state themselves. And so I'm wondering, have any of you looked at also sort of like egocentric experiencing of events? Or I guess, for example, work in autobiographical memory might sort of get at this question for recall of vivid events. But yeah, so have any of you looked at the actual experience of being involved in the event?
That's a great question. And we haven't in my lab, but that's really interesting, and it connects to a lot of things in navigation, right? And a lot of sort of real-world negotiation of the environment. And presumably, action planning as well. So I think it's a great idea.
So I guess that's a uniform no.
Yeah, we haven't done it either. I mean, what I will say is that, the change in a neural state isn't necessarily a change in state of, a meaningful change in the state of the world, right? I mean, it could be something that you didn't predict, but it's a minor, the kind of like, the classic example is like, a moment later versus like, 1 month later. And it's like, that's a massive subjective change in your mental model of what's going on, but it's not a big change in the world, like, the amount of state change you'd get in, auditory cortex is probably not that much, right? So I think some of it is the states depend on what our previous representation was and how much the current information deviates from it too. And that might be more of what goes into the subjective mental state that you're talking about.
So this might be very naive, but I thought there was this notion of schemas, frames, whatever you want, events. The idea that there was a structure that cut across content, almost like, in a Chomskyan sense, a deep structure, sets of rules that kind of define this domain. So my question is, one, does anybody believe that kind of idea? And perhaps relatedly, in neuropsychology, there was always this notion and data about frontal lobe mechanisms, work of Tim Challis and others. Yeah, that seemed to be critical. There was very little talk about frontal lobe. So one, is that like an idea that's still alive? This notion of kind of a rule-based structure to schemas cutting across the actual content. And secondly, what are people thinking about frontal lobes?
Yeah, I think there is, right? So I think at least Anna and me would think that, yes, there are some very abstract notions that people use to interpret events. especially actions. Right? These were very, very abstract notions. Some of them are general, like, I mean, this is also an answer to Anna's question, what I think about how general is the idea of infants interpreting events in terms of schemas. I think we have very good evidence that infants are interpreting observed actions in terms of goals, and these are also, they also imply some kind of abstract notion of agents who actually perform these actions and goal states, and also the relations between means and ends, in a certain sense. These are very, very abstract notions. Now, beyond that, what I presented today, I didn't present evidence of that, but I think that some of more specific schemas are also there from very early on, probably innate, but I don't have any evidence of that. For example, like the ones of giving, which would bias infants when there are alternative interpretations to actually end up with a very specific ones. But of course, if they have a more general notion of goal-directed actions, right, that they can learn about the world, they can learn other kinds of structures in which there are agents, patients, arranged in a completely different way, right? So for example, I mentioned that giving is how different it is from disposing, right? And there is no patient involved in that, and they don't even learn the labor for that. But we have other evidence, for example, that infants understand that's a goal-directed action. That's a proper goal-directed action, just relocate an object to a different place. I don't think that they have an initial schema for that, but they can learn that that's a valid goal-directed action. So having these abstract notions in place, it doesn't replace learning. It makes it possible you to learn about events and actions in the world. That's what I think about this.
I can say something, but you should go first. You'll probably say the smarter thing. So I think it's a great question. This goes back to this idea of, like, some of the weakness of this event cognition work in general is that it's passive. It's like you're watching a movie, it's not, you're doing something. So the two answers I could say, so first of all, there is a literature, so for instance, David Batter is doing great work on learning sequential actions, so that you basically look at, making pancakes or something like that, And that is or in his case, he's using more abstract tasks that people learn this sequential organization for. And this kind of brings up the whole problem with just generally saying schemas. It's sort of like semantic memory, right? I mean, there's so many people who say, this is not episodic memory, therefore it's just semantic memory. It's all one blob, right? And so, if you have an action-centered, sequence that's generalized, that's probably different than something that's more situationally based, right? If it's something, and it's probably going to be represented differently. So that's part of the answer. That if I had to throw a dart, I would throw it at the dorsolateral prefrontal cortex, because that's where David Batter would, On the other hand, for medial prefrontal cortex, as you mentioned, there's a literature on this. I believe Tim's work and Jordan Grafman's work is focused on medial frontal cortex as being the home of scripts, for instance. I know Jeff Zaks really likes that idea that prefrontal cortex is really involved in the event segmentation process and event representation. My own feeling is, and this is just, nobody's really tested this, but I don't like the idea that some part of the prefrontal cortex is doing something fundamentally different than what we think the rest of the prefrontal cortex is doing, which is sort of using context to modulate, kind of posterior representations or action selection. So what I like to think is that in the medial prefrontal cortex, you're basically kind of resolving, at an event boundary, what happens is you're saying, okay, I need to figure out, based on the cues that I have in front of me, what's the most likely situation or schema that could have generated this set of information. And so if you had a medial prefrontal lesion, you would look like you didn't have knowledge about the scripts or the schemas, but it might be in part because you're just not selecting it, right? It's like if you have frontal damage, you will have visual impairments, and those visual impairments will be in part because you're not using goals to direct your eye movements or your attention. And so I think the prefrontal cortex is probably a huge player in this. But if I had to put my money, I wouldn't say schemas live there, but what I would say is that you need the prefrontal cortex to say, this is the class of schemas that I need to be focusing on given what's going on.
So this might be a naive question, but even if it is, maybe it will be a useful one. So I've been thinking about, events, obviously, and I found as well that when I've talked with events to different people in different fields, they'll have different meanings for it. I mean, a classic one is in conversations with people who study language but are more on the linguistic side than psychology. I'll often think of events and talk about them like episodes, right, as a memory researcher. They'll really talk about something completely different, and I usually come away far more confused than I went in, and sort of swear never to have those kind of conversations with linguists. And I also think that if you talk about members of the public, if they ask them what an event is, they'll say, well, a symposium, right, or a meeting, or I'll go to an event. They don't really kind of talk about event in that. And naturally, we can kind of break up temporal, I almost said events there, but temporal sequences are with different granularity, right? That's pretty clear. But we all are sort of settling in, or more or less, at one common temporal kind of component, more or less, compared to the tiniest to the largest event. So my broad question is the level of granularity that you have been talking about, is that one of convenience as a researcher, or is it because it's truth and is a meaningful size of event in the brain?
That's a great question. How much time have you got? So, let me just say, you probably haven't been talking to the right people in language. If you come away confused, I'm sorry about that, but, keep trying. That's just, so granularity. It's a very interesting question to think about whether there's something like a basic level for events, right? So for objects, we assume that, people will look at an image and say dog, and they won't say anything beyond or above it, right? Events work differently. It's hard to see how, with events you don't have a single hierarchy. You have multiple possibilities, right? Multiple levels of representation. And so, I think it's an interesting question to see what is the sort of right level of granularity to think about these things. In our own work, you probably saw a sort of a difference in perspective among the speakers. So there's people who are brave enough to study events in all their naturalistic glory, right, and have very rich, movies or episodes, and then there's people sort of on the ends of the stage here that are looking at very simple, right, people who study infants or people who study language and want to look at these things that are, I wouldn't even call schemas, but I would call sort of the logical biases or the basic structural units of event representations, like roles or boundaries, like very, very abstract things that you can maybe study more easily when you have an isolated, right, bit of the event. So to some extent, I think, this is a question for everybody. I think to some extent in the work that we do, some of the decisions we make are driven by what it is that you want to, discover, right?
All right, well, I'm looking at my watch, and it's 6 o'clock, and in Italy, the event that takes place at 6 is aperitivo hour, so I do want to wrap things up. Just a few things to say in closing. First, please join me in thanking all 4 of the speakers for a wonderful day. That was your moment for your standing ovation. Second, on behalf of both Anne and myself, I want to thank the scientific organizers for supporting the idea for this particular topic for the spotlight theme for this year. We had lots of ideas and they got excited about this one. We will probably do this again next year on a different topic, and so I want to encourage people who have suggestions. You get the idea now, which is something that's very broad that connects to central questions about concepts, actions, and objects, but organizes it in a slightly different way. So over the next day and a half that we have left, if you have suggestions or you can email us afterward, we would love to have your input as we think about planning next year's meeting. Are there any other announcements? Hashtag Chaos 2019 is apparently just rolling along, so check out all Mel's photos and be back here tomorrow at 9. Anything else I need to say? Is that it? All right, thanks. Have a great night.